today we want to talk about stuff that cannot be solved in math. And there's a whole list of them that I found that I made up. We have square root, power, couple power ones, square root one, division. We'll talk about there's some stuff of division we'll talk about. That's why there's a positive one and a negative one. We'll talk about that in a minute. Then there's log, there's a whole bunch of log ones where you can't solve for it. And then there's another exponent one where you had -4 to the half power, which is basically square root. Since the 2 is in the denominator, it's square root. Anyway, this here is, well, if we're talking about, if we're dealing with all real numbers, we answer has to be a real number, then there's no solution to it. Same thing with this one here. It's all real numbers. We have to use all real numbers, not imaginary numbers, because this is when we have a negative square root, you get imaginary number. Now, if you have imaginary number, which it looks like I times I, it should come out to negative 1. Now, you might be thinking, how can something times something come out negative 1? Well, that's the rule of imaginary numbers. If you multiply it together with the same thing, they don't cancel out. They just become negative 1. Or negative whatever the number is. Okay, there's that one. Now, next one is 0 raised to the power 0. Why you cannot do it? Well, anything raised to the power of 0 should be 1. And of course, if it's 0, it cannot be 1. And I think it cannot be half. Let's see if that's another one. Half raised to the power of 0 is 0, but something's weird here. Okay, if you get 0.5 raised to the power of 0, it equals 1. And then if we take 0.5 raised to the power of 1, you get 0.5. How can that be? Well, I don't know. It's less than that, and when you go up, it goes lesser than the first one. You go to 1, make this exponent 1 or something. Anyway, 0 cannot be done with it because basically 1 is greater than 0. But we saw that if we had 0.5 raised to the power of 0, it comes out to 1. Which is, yeah, it did. 1 right here. As you can see on the calculator, if I take If I take 0.5 to the power of 0, instead of giving me an error, it gives me 1. Why is that? If you know what that is, please leave a comment. Why is that happening? Because then when we go to 1, it goes less than that. Anyway, 0, we know 0 is 0, but 0 can't be done because I don't know. That's weird. If 0 can't be done, why can't 0.5 be done with it? That is weird. 0.5 should have a problem too. I guess it has to be greater than 0 in order for it to work. And since 0.5 is greater than 0, it works. Let's try 0.5, well, of course, 0.5 with negative exponent will work too, because that's doing division. But you can't have a 0 there where it's negative 1, because if you do that, 0, let's change this around. You probably, if you already saw my video on laws of exponents, you'll know this. X raised to negative 1 equals 1 over x. And since x is 0, we do 0 right there. Now, this will become undefined or positive infinity. Either which way it works. We'll explain why it's called positive infinity and another one, the negative 1 is negative infinity. We'll explain that in a few minutes. Next, here's what we'll explain it by. First one here is negative 1 over 0. Now, if you know how division works, it works by trying to subtract with the bottom number. How many times it takes subtracting the bottom number? Let's try 20 over 5. 20 over 5. Okay? Now that is 20, I think that's 4. I'll make sure. Yeah, that's 4. So it should work 4 times. So if you take 20, take away 5, that gives you 15. Then you take away 5 again from it, it gives you 10. Take away 5 again with that, it gives you 5. And take 5, take away 5, gives you 0. So how many times was that in order to get to 0? That was like 4 times to get to 0. 20 take away 5 is 15. 15 take away 5 is 10. 10 take away 5 is 5. And 5 take away 5 is 0. The whole reason how division works is it's supposed to take the denominator, use the denominator to subtract the numerator by denominator, how many times to subtract it. Sometimes they have to use less than the denominator, they have to lower down a little bit at the end because the number ain't big enough to do it. And then it does something else. But this is just basic. If you're sticking with regular whole numbers, where they have to be a whole number, it'll work like this. Now, let's say we have 1 over 0. So that means 1 subtracted by 0 equals 1. 1 subtracted by 0 equals 1. You see what's happening? It's continuous, going on and on, equaling 1, never getting to 0. Because he's subtracting 0 by it. This is why it's called positive infinity. Another 1 take away 0 equals 1. No matter how many times you do this, it's always going to equal 1. And that's why we sometimes call it, it's using program languages for referencing positive or negative infinity, like Delphi. He references the floating point number to an infinity number by having it's equivalent to something 1 over 0 for positive infinity. Negative infinity is negative 1 over 0. And this is why they call it infinity, because if you do it, you do it out like this, no matter how many times you subtract, it's always going to come out to the same number. That's because you're subtracting it by 0. And no matter how many times you do it, it's going to always come out to 1, come out to the numerator. And it'll never, ever reach 0. That's why it's called, this one here is called positive infinity. That symbol is infinity symbol. Now let's say you have negative 1. We'll try that one. The same thing. It's going to do the same thing. Watch. Negative 1 subtracted by 0 equals negative 1. Negative 1 subtracted by 0 equals negative 1. And you have to do that. You have to keep subtracting by the denominator. Or or if it gets too low, you make it where if it comes out the only time you change the numerator, the denominator, is if you subtract it and you get negative number. That means that you have to lower the denominator on the last one to see how much you can subtract it by. But this is just basically simplified with doing subtraction of whole numbers, using division of whole numbers. It's supposed to come out to a whole number. And it does the same thing. It works the same exact way. That's negative 1 now. No matter how many times you do this, you're going to always get negative 1. Since it's a negative number, we call this negative infinity. Now next one we're going to do the logarithms. Logarithms, we have a whole bunch of them that are good examples of how we can't do it. Log 10 over 0. Well, you know that any exponent can't give you 0. That's why it's not good. Nor can it give you a negative number, I think. No way can a exponent be a negative with it on there to come out evenly. Because watch, let's try 10. I'll try it over here. I'm going to take 10. To see if I take 10, my special calculator here has a logarithm function on it. Unless you specify the base of it, we'll put 10 there and put 0 in there. And watch what happens to hit equal. You get math error. The reason why it's telling me that because it means there's error in the math. And so let's try some examples, shall we? 10 raised to 0, that's 1. 10 raised to negative 1, that's not 0, it's 0.1. Close, but it's still no cigar. You can't have an exponent of 0 that comes out. You can't have nothing. What I mean by this, what I'm trying to say is you cannot have any exponent with this number to give you that. You can't have no exponent with that be 0 to give you the number of what you're trying to do the logarithm of. Basically, well, logarithms, if you watch my video on logarithms, well, it's probably not there no more. I have to re-upload it. I hope I have it. I might have to redo that video. Anyway, logarithms, what they do is it's like exponent root. You try to figure out what a root, what an exponent would be. And what it's trying to do is make a way where you raise the base to the power of something, gives you that number. But you see we have 0 there. We can never get to 0 with exponents. No matter how hard you try making that there like that, and it just comes out to 1.225. See, cannot never get to 0. Now next one here we have a log of 1 over 10. Log of 1, log base 1, 10. Now you know there is no base 1 log. It cannot be done because what's the... Because log, who watches, so I put log 1 and do I have 10 in the number, 10 in the, there, we'll put 10 there, get math error. So that one cannot be done either. Told you. Now I'll show you why it cannot be done. It's because if you take 1 and raise it to the power of 2, raise it to the power of anything, infinity of numbers, you always get 1, like 1 squared is 1. 3, 1 to the power of 1 cubed, 1. I wonder if I put in a log, try to see what it does. You still can't do it with 1, even though it comes in, even though it's a possibility. The whole reason why you can't do that is because there's a whole list of possibilities, because it all come out to 1. So you could say that's infinity, because it has all the numbers are the same. Now next one, we got log base 0 of 1. You can do 2 to the log of 1, I think. Yeah, you can do it and it comes out to 0 always. But if you do log of 0 to 1, you'll get an error. See? And the reason why it's doing that, I'll show you something else here before we continue on. If I have a log of 10, well, this is how you do logs of any base. I think you do it by, does the base come first or does, let's try it out. Okay, so it's log of your number. I had to do check for a minute here. Log 4 over log natural usually 2. Now let's try this. What would happen if I put log 1 in there, like you see there, over log 10 of 0. This is all base 10 log, but it's used to make up another base. That's how you do it. And what happens is it comes out the error. But why? Let's take a look at log of 0. Let's see what happens in a log of 0. It comes out to an error. But I've hit log of 1. So if I put log 5, we'll do it as log of 5 over 0. You get error. Now if I take log 10 of 0, should get log 1. Actually it's log 1. Oops. Log 1. Usually 0. So if you have log 1 of 0, what happens if you put 10 log by 5, and then down here put log of 1, you get error because you divide it by 0. That's why it cannot be done. Then there's another log, one negative 1. Now you can't get negative numbers in your log. Negative numbers don't work in log. Watch. If it log negative 1, you enter, you get math error. Now now let's try some stuff out here. Let's say we have negative 1 in parentheses raised to the power of 2, gives you positive 1. But you can't have negative numbers in there. It just doesn't work in log. Then our next one, we have log base 10 and has a negative number of what we're trying to do the log of. So if we take log of 10 minus 5, you see we get an error. I think I just did that before, yeah. Basically, you can't have log of negative numbers. That's all it is to it. So I hope you enjoyed this video. It's nicely making. So if you like it, please subscribe. There are more videos like this coming soon. So thanks for watching. Hope you like it.